Hey everyone, my name is Ronak, back with another video. This is the fourth video in our NLP series. In the last video, we have covered something known as parts of speech tagging. In this one, we are going to cover something known as stemming. So let us get started. So stemming in general in the NLP refers to a process where you get to the root of the word. So whenever let's say we have a massive text paragraph, it is often going to happen that we won't be able to discover any factual basis from each and every single word, and we will just end up by increasing the number of words and the complexities. So stemming is a procedure that can actually get to the root of the word. Now, not always the word is going to hold some particular meaning, but we will get the actual stem. So that stemming, so let us assume that I have words, I have a list. All right, so let us assume some words. Okay, so let me say play, then plays, played, playing. Now if we check all of these four words, you can come across a conclusion that yes, play is the root word, it is its stem, and rest others are just the modifications of the word in order to fit into a particular grammar. But the way the NLP works with a certain form of word is that it is not going to look forward in order to derive a meaning from it. Alright, the meaning can be referred with the mathematical orientation, but what NLP does is it requires you to give it the stem of the word, and it can figure out later on. Even if today I say I am playing, okay, so the sentence is supposed to be I am playing something or something. Okay, so let's say I am playing cricket, but if I say I play cricket, the person is able to derive, yes, there is a grammatical mistake, but the verb is not changing. All right, so giving it a twist with the grammatical expression doesn't make much sense to the NLP, since you are just trying to increase the vocabulary. So if we can reduce that vocabulary to a certain point where you can actually get to the root of the word, the complexity of any of the NLP task reduces quite significantly. So now I will show you some of the tactics with which you can get to the stem of the word. There is something known as Porter stemmer. So there are actually three stemming methodologies when we focus in the NLTK toolkit. Okay, so NLTK is basically natural language toolkit. We have been covering this since tutorial 1. Anyway, so you will have to say from nltk.stem, you have to import something known as Porter stemmer. So this is the most oldest stemming technique. All right, this is the most oldest stemming technique, and this is a class. All right, so you will have to call it using an object. So I'll say Porter. All right, so then you have to say Porter stemmer. So you have actually initialized the object of the class. And the way you can use this, so I am going to write a for loop. So I'll say for w in words, let's say I'll say stemmed words. Okay, so this is the name of the variable. Then you have to say Porter, since it is the object, dot stem, and you have to pass w. All right, and it is going to require a list. Either I can print it. All right, so I can say print stemmed words, and let us now run this. So I'll say pi04 stemming, and it says play, 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 play. So basically it has gone to its root, and I can also enclose this in a list. So I'll say stemmed is equal to list, and here I can say stemmed dot append stemmed words. All right, and here I'll print the stemmed. All right, so I get play, which is the root of the word. Later on, the Porter stemmer, when it was, I think it was discovered somewhere in 80s. All right, it is very old. There was something known as Porter 2. So this Porter 2 is commonly used in order to reduce the time complexity, to reduce the complexity of the algorithm, make it much more efficient for run. All right, so this was invented, and it is known as the Snowball Stemmer. All right, this is known as a Snowball Stemmer. So what I'll do is I'll say snow. This also requires an object, plus it requires the language that you are going to work with. So I'll say English. All right, so this is much more efficient. Let's say if we compare it with the Potter one, alright, which is the Potter stemmer. So I can say snow. Alright, just instead of Potter I said snow, and I do get the same output. Now what if I increase the vocabulary? Okay, so after play, plays, played and playing, I want to say player. And finally if we see, the player is also even the same, and when I run it, the player is not converted into play. Here we have an issue of, let's say, lack of aggressive nature of the stemming algorithm, since there are many cases where you require, let's say, less stemming. You don't require it in too much depth, but there are some cases, there are some projects where you require it to its depth. Alright, in such a scenario, these two are not going to sustain. So there is something known as Lancaster stemming. Alright, so I'll import it over here. I'll say Lancaster stemming. This Lancaster stemming is extremely aggressive. Here I can say just Lan or Lancaster, and I can say Lancaster stemming. So I have made the object, and here I'll say Lancaster, and I'll run it. Alright, so everything is converted to play. So this is one of the most aggressive algorithms. See, the most commonly used, I would say, is either Potter stemmer or Snowball stemmer. But finally, there are some scenarios where you really don't require any single word pertaining to its stem. Alright, you can use anything you want. In such a scenario, mostly people use Lancaster stemming. It is very aggressive. Alright, it is going to go to the all depths in order to get the stem. But usually we use Potter or Snowball, because those are most commonly used, and Snowball actually is much more, I would say, computationally inexpensive as compared to the Potter, because you are actually even specifying the language and everything. Alright, and in order to make this much more, I would say, better looking, what I'll do is I'll just get rid of this and I'll make a list comprehension. Alright, so here I'll say stemmed, and I'll make a list in which I'll say x for x in words I want to iterate. Alright, and this will be enclosed within the Lancaster stemming. Alright, so here I'll say x. So Lancaster, so only Lancaster stem x if it is available in the words. That is the meaning. And if I run it, I get the same output. Similarly, instead of Lancaster, I can say, let's say, Snowball, and the output is going to change. And similarly for the Potter. Okay, and we have it. Alright, so this is it about the stemming. Not much more to cover. Quite easy concept. Okay, I don't think there is much more to cover in this one. And I hope you might have learned something or the other from this tutorial, and this code will be available to you in the description box below. Alright, so thank you for watching. Goodbye.